Hey guys, this is Kevin, and today I'll be talking about add two numbers, which is the second Leetcode problem, and it's a medium problem. So the goal is simple. It's given two non-empty linked lists representing two non-negative, so including 0, integers. Return their sum as a linked list. So given two non-empty linked lists representing two non-negative integers, return their sum as a linked list. So the problem is basically addition, but with linked list as inputs. Some additional information that they give is that the linked lists are stored in reverse order. So the first node would have the ones place, the second node has the tenths, and so on. And there are no leading zeros, so the last number will never be 0 unless the number is 0 itself in full. The difficulty in this problem isn't from the addition, it's knowing what a linked list is, as well as how to pull values from linked lists, as well as finding solutions for the edge cases of addition of linked lists. So what are linked lists? If you don't know what these are a data structure, and it's made up of nodes that store values/data. In Leetcode problems, it's usually going to be some data and pointers. So if you look at this diagram here, the first node is this one. So there is a head pointer typically that points to the first data or the first node object. And within the node object, there's going to be some sort of data storing some sort of attribute, and also this next pointer. And this next pointer only points to another node, or if it's at the end of the list, it points to null or none. So how do you access the data in a linked list? Because in an array, right, you have indexes, so starting from 0, 1, 2, 3. But here, you can't really see the indexes, right, unless you code a certain data attribute for them. And even then, it's not easy to access any particular node. So the easiest node to get data from is your current node. Like for example, if you start with the head node, you will see this. And if you say node.next, then you're referring to this node. So node.next.data, for example, would get you the data from this node. But this gets confusing because you can easily lose track of the data. So for example, if you're on this node, well, what do you want to do? What do you do if you want to access the data in this node? Well, you could call next. You could also just move your current node to the next node and access the data. But which one is better? And it really depends on the use case. So we'll be talking about that later in this video. So some considerations on the addition part. So these are edge cases. So very normally you would just say, oh, well, you can just add them together and return it. Well, what if the nodes, the inputs are both one digit, so 5 and 7 is the example, and it needs to return 2 digits, right? So it needs to return 12 backwards, so 2 then 1. And additionally, what do we do when the inputs have different lengths? So this is 12, and then this is 345. And you can say, oh, 2 plus 5 is 7, 1 plus 4 is 5, and then this ends. But we still have this 3, and we potentially have this overflow condition of like, we need an extra node to be added. So here are some examples, and I've drawn these linked lists in such a way that it's very easy to visualize. So for example, this 342 here is actually represented as this visually, but remember the actual structure of it is 3 at the end, 3 at the tail, which points to null, and then 4 points to 3, and then 2 points to 4. So this is the first example that they give on the website, and it's pretty simple, just looking at it. So 342 plus 465 is 807. So this is the ones place, so 2 plus 5 is 7. This is the tens place, 4 plus 6 is 10. 10 ends with 0, and we have this carry of 1, so 1 plus 3 plus 4 is 8. The second example is just zeros, so 0 plus 0 is 0. And the third example is this long linked list of all 9s, and just adding them together gives you a very large number. So, like I said again, the concept of addition is not where the difficulty comes from. The hard part is making addition happen, like accessing data from 2 different linked lists and combining them into one singular linked list. So let's start with the basic example. This is the very, very basic case. So 1 digit, no overflow, no edge case. It's just 2 plus 4 and return a 6. Well, we can just say this is given as L1, this is given as L2, and we can just add them together and create a new node and store the value 6 in it. And when is our stopping case? When we finish adding the numbers. So this node is checked, this node is checked, and that's it. That's all we have to do. Now it gets a little bit trickier with edge cases. So remember, we need this carry of 1 because 5 plus 7 is 12. And if we just did our stopping, like after we finished the nodes, then we would just get a circle that says 2, a node that says 2. And to do this, we can actually add a variable called carry and isolate the places. So we calculate the addition, which is 12, and then you use the modulo, which is basically remainder operator, and you get something like 12 mod 10 equals 2. And then this is the floor operator. I'm writing this in Python, but this might look different for depending on the language you use. And basically 12 / 10 returns the largest number, the largest integer that 10 can go into 12. So that's just 1. If I use divide here, like a single slash, it'll return 1.2, which is not what we want to store because all the nodes are integer values, and yeah. So when do we stop? When we reach the ends of both input lists and the carry is accounted for. So when the carry is not 1, then we can stop. But if the carry is 1, we need an additional node and perform additional addition of any nodes if there are any. Yeah. And the last edge case is different lengths of input lists. So this is like 12 plus 5 is 17. But if we do it with just stopping at the end of either input list, it would be 2 plus 5 is 7, and then just ends there. And we want to make sure that this node is seen even though this node ends after one loop. So 5 plus 12 is 17. The 5 had no leading zeros, but we can add an if statement or a condition where if this node points to null or none, and this list is still not finished, so this one of them is not null and one of them is null, then just treat the null like a 0. So even though they don't give the leading zeros, for example 5 pointing to 0, you can actually just replace that with an if condition to return a 0 in that case. And then that is the final edge case to actually start solving. So this is what the solution kind of looks like in Python. And this is, above this, they kind of define what a list node is, but I'm just using the standard definition of list node, and I set that to output. And I'll step through this code because it's a lot to look at, but pretty much from what I've said in problem solving, it's kind of create a node and you're going to move through the nodes and evaluate, what digits you need, and then add that node to the end of the list. So with example 1, 342 plus 465, these arrows here are representing where I'm going to talk through the code for this slide. Okay. So we define an output as a list node. So basically this creates an empty node that points to null. Then we define current node as the output node. So we add a pointer or a reference to this node here. And we also establish a carry variable that's set to 0 by default. Now, we enter the while loop here. So while L1 or L2 or carry. So effectively this means while there's something in L1 or there's something in L2, or if the carry is not equal to 0. Because if carry is equal to 0, it would be 0 or 0, which evaluates to or false, basically. So while any one of these things is true, then you go into the while loop. If you run out of inputs from 1, if you run out of inputs from 2, and the carry is 0, then you skip this while loop. So what do? We take the number 1, which is L1.val, and this is accounting for the base case of different lengths. So if L1, if you actually have a number, otherwise it's 0. So pretend this 2 isn't here, and pretend this 4 isn't here, and this just points to null. So when you're evaluating, if it points to null, it just returns 0. Because that's if null, else 0. So if null, then the else evaluates. And the same thing for number 2, for the list 2. And then we just do addition. So we add the numbers num1, num2, and carry, which is 0 for the first one, but it could potentially increase in the future loops. And now we isolate the digits. So the digit here is valued mod 10, which gives you 7. And the carry is value divided by 10, rounded down. So that's 0. So what this is the digit is actually what we want in the node. So this line of current node.next equals list node digit creates a list node, a new node, with the value of digit within it. So what that does is it creates this node, it adds a value of 7, and then this node, this new node, points to null. And then we move the current node to the newly created node, current node.next. And since we finished this operation, we want to move both the inputs from 2 and 5 to the next digit, 4 and 6. So here, L1 equals L1.next, L2 equals L2.next. And we also add the if L1, if L2, else none. Because this is also the edge case of different lengths. So stepping through this, we are back to the while loop. So num1 updates, num2 updates. So that's 4 and 6. And then value is num1 plus num2 plus the carry. The initial carry is 0. The value is 10. The digit is 0 and the carry is 1. So we're actually creating a new node with 0 and then updating the current node to that next one, and also shifting from 4 to 3 and then 6 to 4 to prepare for the next one. And then we finished. So using the recent carry of 1, we collect our new values of 3 and 4. And you add that, it becomes 8. The digit is 8, the carry is 0. And you create a new node with 8. And then you check the while condition for the last time. So while L1, this is none, or L2, which is none, or carry, which is 0. So the while doesn't run, and it returns output.next. So why does it return output.next? Well, this is output. So output.next is actually our solution, because the head of output is an empty node. We don't care about this. But output.next gives you the sum in reverse order. So 342 plus 465 is 807. And the final number points to null. And that's the solution. So in terms of time and space complexity, time is just iterating through the linked list and creating nodes with values, and creating nodes and kind of adding them to the end is constant time. But iterating through the linked list, you need to pretty much go through each node one at a time. So it's just n, where n is the length of the longest linked list. And for space complexity, we're storing the initial input list of O and N, and we're also creating an output linked list, so O of N. And overall, it's going to be O of N in both time and space. And you can see the distribution here is pretty much in the middle, but beats 33%, beats 53%. And that's how you solve add two numbers.